Hey 12s, a couple more properties of definite integrals, right? We went through a few in the previous video, and we split it up to make the video a bit shorter. So, a couple of things here. Should I work from right to left instead of left to right on my integral? Then I get the negative answer, right? I get the same answer, but multiplied by -1. Right, think about this, that if I did something like 5 minus 2, right, I get 3. If I do 2 minus 5, I get -3 because subtraction is not commutative. Right? The order is important when I subtract things. So, if I run it the opposite direction, if I go from B to A instead of A to B, I will get the negative of that answer. Yep. Okay, that's the first of these properties we're going to look at in this video. The second property is sums of functions, right? If I have some f of x plus some g of x, and I integrate the sum of those functions, well, it's the same as the integral of f of x plus the integral of g of x. As long as they have the same bounds there, A and B, then I can split that up. And I'm just going to do a little worked example here, just to sort of see how that goes. Right, it's not going to prove it, but it's going to confirm it. So, jump straight in with an equal sign here. I get 1/3 of x cubed plus 1/2 of x squared plus x between 0 and 1. Now I reckon that gives me a 1/6 plus 1/2 plus 1, not a 1/6, a third plus 1/2 plus 1 is going to give me 5, 11, 1 and 5/6. 1 and 5/6, yeah? Cool. Now let's do them individually. Right? And this will give me 1/3 of x cubed from 0 to 1 plus 1/2 of x squared from 0 to 1 plus x from 0 to 1 equals, well, you know, 1/3 plus 1/2 plus 1 equals 1 and 5/6. Okay, the same thing. What do you know? So we can chop that up if I've got a sum. What else have we got here? Just a couple more properties, nothing too complicated. Multiples of functions. Right, if my function is multiplied by a constant, I can drag that constant outside. Right, I can drag it outside there. And run that integral without the constant, without that multiple, and just multiply my answer. That's all good. A good example of this is we will see pi sneak from sort of the inside to the outside in some examples later on. And finally, the last of these properties that I want to talk about, we're not actually going to work through, but we're going to talk about is an inequality. Right? If I have two functions, f of x and g of x, if between this interval from a to b, if f of x is always less than g of x, right, so let's say let's call that g of x, and let's call this one f of x, and we want from a to b, right? Seeing as f of x, this curve here, is always under g of x over this interval, then this area here is definitely going to be less than that area there. Okay, so if f of x is less than g of x, then the integral of f of x is less than the integral of g of x. Okay, that inequality will hold true as long as they don't intersect anywhere along the way. All good? That's the last of those properties. That'll do us for now. Thanks, Charles.